In this lab, we'll try to use container. We just use container because maybe on DataLab there have no enough resource we can use. So some nodes we have to run on a virtual machine. So first we need to create an experiment. First of all, we need to try to log on users. E542 is our project name, and then followed by our experiment name. Here, experiment, you can name everything you want, and then follow our scripts, TCL script. Before we start our test, I have already submitted all my example TCL scripts onto user's home directory. So you can run it. You need to wait a moment. Here we can look at example 1. Then our experiment have created successfully. Then we can look at his topology diagrams. This is example 1. Before we try to enter into any node, first we need to swap in our experiment. Here I have already swapped in experiment, and then we can SSH to any node we want. Here we try to SSH to node 0, and then we can ping centers in any other node to try to our connection is correct or not. For example, here we try to ping center first. It does works. And then we try to ping some other one node. For example, here we try to ping 02, node 2. It also does work. In example 2, we'll try to change our container type. Container type have some of the types like QEMU, OpenVZ, process, and also can set it to equal to embedded P node, means run on physical node. Here we have some errors because to QEMU type, there are only at most 7 experimental interfaces. So we run it. We run our example 2 TCL script. We can see that in our example 2, we have already changed satellites less than 7, so it does works. And in our next example, in example 3, there have totally 10 satellites, and we'll use mixed containers. Some run on QEMU, some in the center run on process. Yeah, you can see that example 2 have already created successfully, and we can try to create example 3. Okay, in example 3, just like we said, the center is on process, and others will run on QEMU. And in next example, example 4, is also a mixing container. In these examples, we'll have totally use 3 container types, QEMU and Will OS, and only node 1 will run on physical computer. Yeah. We can see that example 3 have also created successfully, and we continue to run on our 4. Yeah, when we our example 4 finished, we can look at only node 8 on one physical node, and all of other nodes will on the same another physical machine. And next, our experiment just need to cite in our OpenVZ or QMU parameters. There have some template we can set, and we also can set bitwise and our virtual machine disk size. Default disk size is just 2 gigabits. We can set another value. For example, we can set here. We set disk space is 15G, and template is Ubuntu 12.04. After our example 4 experiment created successfully, then we can run our example 5. In example 5, we'll set our center on Ubuntu 12.04, and other nodes will set disk size to 20 gigabits. Please wait a moment. Next, we'll test packing set. Here we set packing 2 means on each physical node we only run at most 2 containers. We need to wait a moment. Okay, it finished. Let me run 6 first. Okay, let's see the topology about packing 2. Yeah, you can see that each P node there only have at most 2 containers on that. And then example 6, we also can see that we set containers. There have 3 physical nodes. On each physical node, we have totally 20 subnodes. And now 6 have already finished. We can check it topology. Okay. Yeah. This is our topology. We can see that this is 1 line, 2, 3. There are 3 lines, and each line there have totally 20 nodes. And now it's just not balanced to split this node to different physical machine. We also can through set some parameters to set on each physical node. We hopefully how many nodes on there, and we also can set does we need to this even split or not, and also can set we want to split how many machines. Now we'll next try to this part. Through ParsePark to set on each machine how many nodes we want to include it. First we set it center is just one machine and the others is 20, 10, and 5. And another experiment will set 20, 11, 6, and we can see there have difference. Yeah, this machine we can see that the line 0 we use one machine, and there we use 3 machine. Here we use 5 machine. If you feel there have so many physical machine we used, we can just set bigger size of each site, and then we can see that if we set it to 20, 11, and 6, and now there have only 2 machines be used, and here 5 machine used, and there is only 4 physical machine used. In the last example, we also can use part size to limit our machine numbers, and we also can use ParsePark and part size together. Now we have run them successfully, and we can check its topology. In 2, one machine, this line is only use 1 machine, and this line use 1 to 2 machine, and this line use 1, 2, 3, 4, 4 machine. This is just we configured that 1 machine, 2 machine, and 4 machine. And the last one we set the first machine is 10. We can also count the last topology. Yeah, this is our last topology. Line 1, there have totally 10 machines, and each machine equally have 2 nodes. Just like we said. We said 1 totally use 10 machine. And other lines we set its pack size is 5, 10, and you can see that 1, 2, 3, 4, 5. It's use 5 physical, and this no, it's 4. 5 just means 1 machine at most 5 nodes, so we can say it's equally 4, less than 5, and last is at most 10 nodes, so we can say it's for example here is 7, and we totally just 7 or 6. It's also less than 10. So we can set so many parameters to establish and set up our topology and our machine numbers. Thank you for your attention. Have a good day.